The story of 3I/ATLAS just took a turn that no one expected. Because for the first time since perihelion, astronomers have finally managed to capture new images of the most mysterious interstellar object in history. Yet, the clearest, most important photograph of all remains locked away from public view. On November 2, 2025, researcher Kang Zhang from the LOL Observatory in Arizona trained his 152mm Ritchie-Chrétien telescope toward the morning horizon and caught what everyone had been waiting for: a fresh visual confirmation that ATLAS had survived its fiery brush with the sun. The object shimmered faintly against the twilight, glowing blue even through atmospheric distortion. Despite light pollution, low altitude, and unstable seeing, the interstellar visitor stood out: small, steady, unnervingly bright. At first glance, the photo looked ordinary, but to experts comparing it to pre-perihelion data, something was off. The hue was bluer, the magnitude brighter, and the object's motion slightly inconsistent with projections. Every frame hinted that the enigma surrounding ATLAS was far from over. And yet, this modest ground-based photo from an independent observer is not what has scientists whispering behind closed doors. The real controversy centers on an image captured a full month earlier, one the public still hasn't seen. The missing Mars image. When Atlas crossed near Mars's orbit on October 3rd, it passed within roughly 27 million kilometers of the red planet, close enough for the Mars Reconnaissance Orbiter to obtain crystal-clear, high-resolution imagery with its high RISE camera. The event was routine at first. The probe automatically logged the encounter between October 2nd and 3rd, transmitting terabytes of data back to NASA's Jet Propulsion Laboratory. And then, nothing. The dataset vanished from public feeds. Archival timestamps abruptly ended. No thumbnails appeared in the HiRISE queue. In internal databases, the sequence is listed as under review, in other words, locked. For planetary scientists, this is unprecedented. Normally, HiRISE imagery becomes public within days, sometimes hours after downlink. But a full month later, researchers still can't access the files. Multiple institutions, including the Harvard-Smithsonian Center for Astrophysics, the European Southern Observatory, and several university consortia, have all filed formal requests for release. None have received a reply. Unofficially, rumors swirl that the photos reveal structural geometry inconsistent with natural comet morphology, edges, shadows, maybe even repeating patterns. Officially, NASA says nothing. Public assurance, scientific silence. The silence would be strange enough on its own, but what came next turned the story into a spectacle. On October 31st, while professional astronomers were still waiting for access, Kim Kardashian tweeted a question to NASA. "Is that blue comet thing gonna hit us?" NASA's verified account responded in less than 20 minutes. No aliens, no threat, nothing to worry about. The public loved it. Memes exploded. The tweet racked up millions of views. But to the scientific community, that single reply felt like a slap in the face. Because the same agency that could answer a celebrity in minutes couldn't find the time or the transparency to brief its own researchers about the most anomalous interstellar object ever discovered. It's not just bad optics, it's a breach of scientific protocol. Every hour that data sits locked away is an hour lost in planning the December 19th observation campaign, when Atlas will make its closest approach to Earth. Without those Mars orbiter images, astronomers are effectively blind. They can't calibrate brightness models, assess jets, or refine orbital parameters. And when you're tracking something accelerating without known cause, even the smallest margin of error can make or break a mission. When agencies go quiet. This isn't the first time space data has gone missing, but it's the first time the silence coincided with panic at the top levels of government. Sources inside multiple research networks confirm that congressional staffers have quietly requested briefings on the MRO imagery. Several European agencies are pushing for transparency clauses through the International Asteroid Warning Network, IAWN. So far, all requests have hit the same wall: pending review. Meanwhile, every major observatory on Earth is scrambling to acquire replacement data. Amateur astronomers are coordinating global tracking schedules, uploading light curve readings to shared databases, and cross-checking each other's measurements. It's an unprecedented collaboration between professionals and hobbyists alike, all trying to solve the same question. Why the secrecy? NASA's explanation that the data is still being processed rings hollow to many. High-rise processing pipelines are automated. Raw images can be posted publicly within hours. The only reason to delay release, skeptics argue, is classification. And classification implies discovery. In the absence of answers, theories multiply. Some claim the images show symmetrical panels. Others whisper about plasma fields, reflective plating, or a metallic glint that persisted even when backlit by sunlight. None of it is confirmed, but the mere possibility has electrified the public imagination. The irony is that NASA's silence fuels exactly what it's trying to suppress. When an agency tells millions of people on social media, nothing to see here, but simultaneously withholds the one dataset that could prove it, the public fills in the blanks. Science depends on transparency. When that transparency is replaced by selective communication, tweets instead of telemetry, the narrative becomes mythic, not scientific. And once myth enters the equation, control is lost. In less than 2 months, ATLAS will pass its closest approach. Dozens of instruments, from ground telescopes to space-based coronagraphs, are already queued for continuous monitoring. But if the Mars orbiter imagery remains sealed, every model guiding those missions will rest on guesswork. And that means one of two things is happening. Either NASA is guarding data that's inconclusive and politically inconvenient, or it's sitting on evidence that rewrites everything we think we know about what's moving through our solar system. Whatever the reason, the longer the silence continues, the louder the questions become. Because in science, secrecy is the one anomaly no one can explain. The mystery surrounding 3I/ATLAS has never been about what we can see. It's about what shouldn't be there at all. Because buried inside its reflected light lies a secret that challenges the foundations of both cosmology and materials science. New spectral data arriving from observatories across the globe reveal something extraordinary. The object's metallic composition doesn't match anything we've ever found in nature. At first glance, it sounds minor, just an unusual ratio of nickel to iron. But dig deeper, and it becomes the most troubling clue yet. Typical comets are built from the universe's leftovers: ice, carbon, rock, and trace metals. Iron always dominates because it's one of the most common elements forged in the cores of stars. Nickel shows up too, but only in small amounts, maybe 1/10 as much as iron, but not here. Spectroscopic analysis of 3I/ATLAS shows nickel levels far exceeding iron, sometimes by a factor of 4. That shouldn't happen naturally, ever. Because nickel doesn't separate from iron without deliberate intervention. To refine nickel-rich metal with minimal iron contamination requires controlled conditions: chemical separation, electrolysis, or high-temperature smelting, processes that demand furnaces, electricity, and intention. In simple terms, nature doesn't make metal this pure. Machines do. Even Elon Musk chimed in recently, tweeting that nickel and iron are common cosmic metals. But materials scientists were quick to correct him. Yes, they're common, together. What makes Atlas so strange isn't their presence, it's their proportion. The ratio itself tells a story that no natural comet can explain. So, what does that purity mean? There are two main possibilities, and both are staggering in their own way. Scenario 1, 3I/ATLAS, formed in an unusually metal-rich system, a region of space born from multiple generations of dead stars, where supernovae had seeded space with heavy elements. That would make it a young interstellar object, forged in the aftermath of stellar death, possibly from a civilization's home system that's far more evolved than ours. But there's a problem. Even in the most metal-rich star systems, the natural ratio never flips so drastically. Something would have to artificially enrich nickel or filter out iron, a process that mirrors how humans manufacture stainless alloys or aerospace metals. Which leads to scenario 2, the one scientists are reluctant to say out loud. The material isn't found, it's made. And if it's made, then we're not just tracking a comet anymore, we're tracking technology. The composition also tells us something else, something just as important: its age. Heavy metals like nickel and iron aren't ancient cosmic dust. They're latecomers to the universe's timeline, created in the fiery hearts of dying stars. The more metal you find, the younger the material usually is. That means Atlas isn't some billion-year-old wanderer. It's young. Its metallic purity suggests formation within the last few 100 million years, an astronomical blink of an eye. So now we're looking at an interstellar visitor that's both metallically refined and cosmically young, a combination that shouldn't exist without someone, somewhere, crafting it. And yet, the metals aren't even the strangest part anymore, because if you take the data from ALMA and SOHO at face value, the object isn't behaving like a chunk of rock and metal at all. It's behaving like a controlled craft. Measurements taken around perihelion revealed a measurable non-gravitational acceleration. In other words, something pushed Atlas faster than gravity alone should allow. The physics is straightforward. If a comet speeds up, it's because gas or dust is venting from its surface, tiny jets acting like thrusters, conserving momentum. But to explain the velocity change we've seen, Atlas would have needed to shed around 5 billion tons of material. That would create a debris cloud visible for millions of kilometers. But telescopes scanning the region, both ground-based and orbital, see nothing. No coma, no outgassing, no plume. It's moving as if invisible engines are firing. Avi Loeb calls it the mass loss paradox, a contradiction so sharp that either our physics is wrong or the object is being driven. If this were a normal comet, its brightness would fade after losing mass. But since perihelion, it's brighter than ever, and bluer than the sun itself. That color means energy, and energy implies power. Combine the two, nickel-heavy metal and blue-shifted radiation, and you get a picture that's impossible to ignore. A solid object built from refined alloys, surviving temperatures that would melt most known metals, and accelerating without visible fuel loss. That's not random, that's architecture. Some scientists now believe ATLAS may contain internal heat regulation, something maintaining equilibrium as it endures solar bombardment. If that's true, it's not a rock at all, it's a system. Avi Loeb's team is careful not to use the word artificial. Instead, they describe it as a phenomenon consistent with energy management. But for many in the community, that's just cautious language for a far bigger implication. It's powered. Between now and December, telescopes will be hunting for confirmation. If the December 19th flyby reveals no debris, no mass loss, and continued acceleration, we'll have entered uncharted territory. Because then, there will be only two remaining explanations. Either physics as we know it is incomplete, or someone else built something long ago, and it's moving through our solar system right now. The difference between the two is nothing less than the line between nature and design, and the answer might already be sitting, locked away, in the hard drives of the Mars Reconnaissance Orbiter. The more scientists study 3I/ATLAS, the clearer one truth becomes. This isn't just another interstellar visitor. It's a mirror held up to our understanding of physics, and the reflection doesn't make sense. As of early November, the object officially violates 9 fundamental laws of cometary behavior. Each one on its own could be explained away. Together, they form a pattern that looks deliberate, a design hidden behind a scientific disguise. Let's break them down. 1. The perfect alignment. Atlas travels on a retrograde orbit, moving backward compared to the planets, yet it sits within 5 degrees of the ecliptic plane, the flat disk that defines our entire solar system. In 3-dimensional space, there are infinite approach angles. The ecliptic covers less than 3% of them. So, how does a random interstellar object find the one path that aligns perfectly with the orbital plane of Earth, Mars, and Jupiter? Coincidence? Maybe once, but not when the precision is this exact. If you wanted to explore a solar system efficiently, this is the route you'd take. Low energy, high access. The odds of it happening naturally hover near 0.2%. That's not just rare, it's surgical. 2. The anti-solar jet. In July and August, Atlas broke the first commandment of comet physics. Every comet in history ejects material away from the sun. Radiation pressure and solar wind make that law universal. But not this time. Atlas expelled a jet directly toward the sun, creating what astronomers now call an anti-tail. It's like watching a flag blow into the wind instead of with it. There's no known mechanism that explains this. The only way it could happen naturally would be if the sun's radiation were weaker, or if the force pushing the material was stronger, much stronger. And that means one thing: internal energy. 3. The mass-speed paradox. Atlas isn't just big, it's colossal. Roughly 1,000,000 times more massive than Oumuamua, 1,000 times larger than Borisov, yet it moves faster than both. That's physically absurd. In space, heavier objects move slower when ejected by gravity because of energy conservation. Imagine a cargo ship outpacing a fleet of sports cars. Something's adding thrust. 4. The perfect timing. The timing of its path reads like choreography. Atlas passed near Mars, Venus, and Jupiter, yet stayed perfectly hidden behind the Sun when closest to Earth. That window of invisibility, between October 21st and 29th, occurred at the exact moment when global observatories couldn't observe it. An accidental stealth pass, or deliberate avoidance of the one planet capable of photographing it in detail? It's as if something planned this approach thousands of years ago, calculating planetary alignments with uncanny precision. 5. Industrial metal signatures. Spectroscopy doesn't lie. Atlas's composition shows an abundance of nickel, with minimal iron, resembling industrial alloys, not primordial material. In every known comet, iron dominates. But here, nickel rules. That ratio mirrors how humans refine metals for durability and heat resistance. The implication? Either Atlas formed in an impossibly metal-rich system, or it's composed of refined material. And refined material means technology. 6. The driest object in space. Comets are frozen relics, 80 to 90% water. But Atlas has only 4% water by mass, essentially a metallic desert. For comparison, that's drier than the Atacama Desert or the Moon's South Pole. So, what's a comet without ice? An imposter. 7. The polarization fingerprint. When sunlight reflects off a surface, it leaves a signature called polarization that tells us what the surface is made of. Every known object in our catalogs fits predictable polarization patterns, except this one. Atlas's reflected light shows extreme negative polarization, a property never recorded in any natural object, even Borisov. It's like light is twisting unnaturally off something engineered, not scattered dust or porous rock. Avi Loeb said it best. It's as though the surface knows how to bend light. 8. The blue light of heat. During perihelion, the object's color shifted, fast. It became bluer than the sun itself. That shouldn't be possible. Blue light means higher temperatures, above 5,800 Kelvin, hotter than the solar surface. Natural bodies don't glow bluer as they heat, they redden. Dust scatters short wavelengths and transmits longer ones, making comets redder the closer they get to stars. Atlas flipped that rule on its head, which means one of two things. Either we've discovered new physics, or something inside ATLAS is generating its own heat. 9. The acceleration without mass loss. This one defies everything. If an object accelerates in space, it's either being pushed or it's losing mass. That's momentum conservation 101. But Atlas accelerated and didn't lose a thing. To account for the velocity shift, it would have needed to vent 5 billion tons of material. No telescopes, ground or orbital, have detected that. Not even a faint dust cloud. That's not natural propulsion. That's control. The one truth. Left individually, these 9 anomalies could be rare coincidences. But the combined probability of all 9 happening naturally? Less than 1 in 10 quadrillion. That's lower than winning 15 lotteries in a row, blindfolded during an earthquake. So scientists are left with a choice. Either we rewrite physics, or we accept that something built this. As the December 19th observation window approaches, telescopes from Webb, Hubble, ALMA, and VLT will all converge on a single point in space. If the object remains blue, shows no debris, and continues accelerating, it will confirm what many already suspect. 3I/ATLAS is not a comet, it's a craft. But until those results arrive, one truth remains. Something just crossed our solar system that obeys no natural law we know. And the silence from NASA, the locked Mars orbiter data, and the absence of answers suggest one thing. They're not just studying it, they're trying to understand who made it. If you're following this journey, now is the time to stay close. Because when those high-resolution Mars images finally surface, whether by release or by leak, everything we thought we knew about cosmic visitors will change overnight. This is no longer a question of if there's something out there. It's a question of when they decided to come closer.